Monday, we started working with zeros or roots or solutions or x-intercepts, which are all the same thing. So we were working on describing what happens at each of the zeros in a polynomial function. So let's start by just factoring. Let's just work on finding the zeros. So on number 1 and number 2, you could use a quadratic formula if you want. Number 3, you can't. You got to know how to factor it. So on number 1, remember to find the zeros, you set it equal to 0. And in this one, without a front number, we just look for two numbers that multiply to 15 but add to 8. So we have a 5 and a 3, and we're done. X plus 5 equals 0. You don't really have to write this step. Ultimately, x equals -5 and -3. And those are the zeros. Number 2 is a tiny bit more involved because of this front number. So first off, you could do it in your head. Use some trial and error. Make sure you're using pencil and eraser, not a pen. 2x squared, you don't have very many choices there. It's probably going to be 2x times x. Not many other choices there. I guess you could make them negative. And with 4, you don't have many choices either. It's just a matter of shuffling. Because I want this times this plus this times this to be -7x. And I see a 4 and I see a 2. That'll get me up to 8. If I put a 1 right here, what if I subtracted a 1 from the 8 and I got 7? I need -7 though. So let's get a -8 and a +1. And that checks out. So that's one way. Do it in your head. Or you could use the box method. Or I'm a little obsessed with this other method. It's so easy that a student in second period taught me. So, or you could find numbers that multiply to that number. Well, let's back up, sorry. Multiply first times last, and we get -8. So I need numbers that multiply to -8, but add to -7. Now this is, the red writing is different. We've already factored it in green. We're already done. So if you can do that in your head, then great. But some people struggle with that. So in red, this alternate way, first times last gives me -8, middle number is -7, and -8 and +1 will meet both of those conditions. So here's the trick. You could do the box if you're a pro at the box, but this is faster. Take the two numbers that we just found, divide them by the front number. Here's our front number right here. So divide by 2. Maybe make a note to yourself. That's our front number. Reduce. One half's already reduced. And you're done. It's like a what do you call that? 2-step process? 3-step process? I don't know. Find your two numbers, write the fraction, reduce. Now, you got to put it in parentheses. You're not necessarily done, but we have all the numbers. The denominator represents the x, and the top number is what you combine with the x, so -4 and +1. And that's what we have up there in green. Very cool. Set both equal to 0, and our two x's, our two solutions are -1/2 and +4. All right, so red way, green way, use the box, something like that. Number 3 is totally different. Remember, degree is referring to n. So this has a degree of 4. But don't forget to look for a GCF. It's still factorable. I could take out a negative x squared. Whoops, I took out a negative, so that 4 becomes negative, and that last 4 becomes positive. And then that's factorable. Two numbers that multiply to 4, but add up to negative 4. So many people catch that the answer is 2, but the answer is also 0. Remember, you set each factor equal to 0, and one of the factors is that. So when I set that equal to 0, there's no other number that can satisfy that except 0. So there you go. There's our answer for those 3. Let's look at something new. So you have to be able to get the zeros to be able to do what we're going to do in this section. So this was review, all review right here. The new stuff is called multiplicity. So I'm going to look at factors of my polynomial, and I need to say what the multiplicity is. It has a value, but more importantly, I'm going to say whether that value is even or odd. So multiplicity, first of all, is the exponent above a factor. There's a better textbook definition, but I don't know. Those are the words that I use to think about it. So for example, x equals 2 in this problem is a 0, is a solution. But pause on the 2. The multiplicity is this 2 right here, and it's even. This one has a multiplicity of 1, because there's an exponent of 1 right there, and the number 1 is odd. Now I'm not saying negative 2 in the parentheses is even, or the 5 is odd. I'm saying the multiplicity is even or odd. So for example, maybe it'll click over here in the middle. This one has a multiplicity of 1, which is odd. This one has a multiplicity of 1, which is odd. That one really stands out to people because they still start looking at only the 9 and the 2. But I'm looking at the exponent, which isn't written on this problem. It's just a 1. All right, maybe it'll click on this last one. Multiplicity is 3. Multiplicity is 2. Multiplicity is 1. Now, hopefully you see the pattern. This is an odd number. This is an even number. Odd. And now look at the very top of the page. I need to say one more thing about this. So if it's even multiplicity, and I just discovered I don't have enough room to write this, that means that when the graph is moving towards that x-intercept, if it's even, it bounces off the x-axis. It turns around. That's what I typed up here on the top line. Turns around right there. If it's odd, it crosses the x-axis. So anywhere we have odd multiplicity, I write crosses. And anywhere I have even multiplicity, I write bounces. And that's it today. That's all we're worried about is what is the multiplicity? Does it bounce or cross? So we'll practice that more in Tuesday's video. I'll see y'all in class.